Hey guys, it's Coach Garrison. I'm going to be teaching you guys part 2 for this week's video learning, and we are going to be talking about friction today. So in the first video, Coach Driver taught you guys about what we talked about last week, which was balanced and unbalanced forces and how to calculate net force. So today I'm going to teach you guys about the effect that friction has on balanced and unbalanced forces and how that affects any type of push or pull that you apply on an object. Friction is defined as the resistance that one surface or object encounters when moving over another. A second definition is the action of one surface or object rubbing past another. Okay, so the first type of friction that I want to talk about is static friction. And static friction is the type of friction that happens whenever you have two objects that are in contact with each other, but neither object is moving. The objects are static, which means not moving. When you have static friction and the objects aren't moving, those forces are balanced. So the net force on that object is zero. What's happening is you have two objects that are in contact with each other, but the force that's being applied on those objects is not strong enough to make that object move. A perfect example of this is if you have a big piece of furniture or a refrigerator or anything that's large and you apply a force on that and that object does not move. The force that is stopping the object from moving is known as static friction. Okay, the next type of friction is kinetic friction. And kinetic friction is the friction that happens whenever an object is actually moving. And it can be broken down into some subcategories. So like the big umbrella is kinetic friction. And underneath that umbrella, you've got sliding, rolling, and fluid. So those are all three different types of kinetic friction because kinetic means movement. So anytime that you have an object that's moving past another object, it's known as kinetic friction. So sliding kinetic friction. A perfect example of sliding kinetic friction is you have that refrigerator or big piece of furniture that we were just talking about, but you finally apply enough force onto that refrigerator or object so that it starts to move. So that is known as sliding kinetic friction. It's an object sliding past another. Another type of kinetic friction is rolling kinetic friction. When this happens, you've got something with wheels on it and it's rolling past a static object. So a car wheel rolling or scooter board wheel rolling, any type of wheel moving on the ground, that's rolling kinetic friction. And then the last one is fluid kinetic friction. And that's when an object is moving through a fluid, which would be air or a gas or a liquid. So an example of this would be like skydiving. Whenever you are skydiving, you're diving towards the ground and you've got that air that's brushing past you, that's actually slowing you down. That's called fluid friction. All right, you guys, so I drew a diagram for you to visualize how friction works. And so right here I have a guy in a box, and on this side I have the exact same guy in the exact same box. The only difference is the surface that the guy is pushing the box across. So on this picture, this man is pushing a box across a field full of grass and flowers and lots of stuff. In this picture, the guy is pushing the box across a completely smooth floor like what we have in our science labs. So notice the man is the same size in both pictures. The box is the same size in both pictures. The only thing that changed is the surface that the man is pushing the box across. So if you visualize this in your head, what do you think will be harder for the man to push the box across? The grass or the smooth floor? I'm listening, class. Hello? What's the answer? Oh, it will be easier to push across the smooth floor because of the force of friction. There is less friction on a smooth surface than there is on a rough surface, and so it's easier to push the box on a smooth surface than it is to push the box on a rough surface. So now, I'm sure that you're asking yourself, how does friction come into play whenever we're talking about net force, balanced forces, and unbalanced forces, which is what we've been working on so far? Well, let me tell you. In your math problems that you've done previously, the ones that you did last week and the ones that you did yesterday or earlier today, you always saw the net force diagram's drawn with two arrows, or usually two people, one on each side of a box, pushing against each other or pulling against each other. In this situation, there are two forces that are opposing each other, but it's not two different people, it's a person and the force of friction. So going forward, whenever you're looking at your problems, you will see friction integrated into those problems. So it may say a person is pushing a box to the left with a force of 15 newtons, and the force of friction in the opposite direction is 15 newtons. Would the box move? And in that situation, the answer would be no, because the force of friction is equal to the force that the person is pushing the box with. And that concludes my TED Talk. Thanks for coming to class today, guys. Your teacher misses you. It's Coach G. So, in conclusion, here's what I want you guys to do for me today. Your lab assignment is to put some shoes on and go around your house or go outside and slide your feet across 3 different surfaces. I want you to slide your feet with the same amount of force across 3 different surfaces, and I want you to notice the different feeling that you get on your feet. This is something that you do all the time. Anytime you're in different buildings, your feet will slip on some surfaces and your feet will easily glide across others. But I want you to pay attention, because what you've been doing your whole life, just playing around, is actually friction. Have a great day.